What's going on, developers? Welcome back to another episode in software engineering and Salesforce. My name is Brooks Johnson, and today we are going to talk about Bitwise Operators. So stick around through the end of it. I think you're going to learn something, even if you don't use it every single day. Give it a like and subscribe, and let's hop in and start talking about them. All right, so I have open here the Apex documentation on expression operators. And most of it is what you're used to, right? Division, multiplication, right? Subtraction, okay? But now we have down here these bitwise operators. And if you are anything like me, and maybe you don't have, probably if you have a computer science degree, I know you got introduced to this at some point. For the rest of us, speaking for myself, this stuff was kind of terrifying. Like, this was some black magic, and I would go in once in a while and I would see these and I'd read them. Bitwise AND, right? Bitwise AND operator ANDs each bit in X with the corresponding bit in Y. So the result bit is set to 1 if both of the bits are set to 1. I don't know about you, but like, that's clear as mud. So I avoided this part of the programming language. I was frankly, probably, like I said, a little scared of it and just hoped I would never, ever need it. Flash forward today, arguable whether you'll ever really need it. Bitwise Operations are mostly probably used in embedded system stuff. They are faster than just doing straight math, but typically when you get to the compiler level, these sort of optimizations are done for you. So we could do all the math in the world with bitwise operators, and I'll show that, but I think you would definitely, and you'll see when we get to the end, definitely sacrifice and readability. So I don't know, take the video, decide here, and do you want to bring bitwise operator day-to-day programming? For me, probably not. But I like to understand the entirety of my language, all of the tools that are available to me, even if it's not something I'm going to use every day. So that's where I think maybe the value in this video is. So we are going to talk today. We're going to do AND, OR, exclusive OR. We're going to shift right, shift left, show what that looks like. We're not going to really get into some of the negation stuff, things with signed, unsigned, because that starts to get into two's complement, which is, I think, a whole separate video. If you really like this and you want to get more into the bit stuff, please let me know in the comments, and I'll gladly make more of these super nerdy videos. All right, let's open up Illuminated Cloud and IntelliJ. We're going to do pretty much all of it today. I think we're going to spend just mostly in anonymous Apex. So when we talk about bitwise operators, what we are doing is we're working in base 2, right? We're working in binary now instead of base 10. So I have here, I've got 3 integers declared, A, B, and C, and they are assigned the values of 1, 3, and 4. Right, and so we write these here, right? That's all. These are our base 10 numbers. And over here, right, in our comments, I've written out, like, what is the representation of these numbers? What's the binary? What is the base 2 form of these numbers? So remember, each placeholder so just like each placeholder in base 10 represents a power of 10, each one in base 2, power of 2, right? So here's our 1s. Our 2s, our 4s, our 8s. So 1 just has a 1 bit, right? It's on in the 1's location. Everything else is a 0. There's nothing there. A 3, right? It's represented in base 2 is a 1 bit, right, in the 1s, 1 bit in the 2s, nothing in the 4s, nothing in the 8s, etc. And if we go over, that's wrong. If we go over to 4, right, we can see now 4 has nothing in the 1s, nothing in the 2s, 1 bit in the 4s, right, etc. So this is base 2, right? That's our binary representation of the numbers, and that is what bitwise operators are going to let us do. So if we do bitwise AND, all right, so I'm going to do system debug, A and B. Okay, and I'm going to go over here to my comments, and I'm going to kind of explain this. So essentially what we're doing is creating a truth table. All right. So if we remember, A is 1. So I'm just going to copy that. I'm going to go down over here. And B is 0011. Okay. Now, if we are, whoops, let's get back into the right spot. All right. Sorry, my comments are a little all over the place here, but I just want the numbers to line up. So remember, just like an and, right? If both things are true, it's true. If both things are false, it's false. If one of them is true, it's false. So what we are saying here, when we and these two binary numbers, we're going to say, you know what, we're going to just work, in this case, from left to right, because we're saying, is there anything, all right, we know that's false, there's nothing there. That's false, there's nothing there. There's only one thing that's there, so we're going to say that's false. There is but for both of these numbers, there is a 1, there is a bit at the ones position. So when we and A and B, that's what we end up with our binary representation. So let's run that. System debug. So that's what we get. When we anded A and B, the result was the base 10 number 1, or this is what it looks like in binary. So that's all it looks like, as we are comparing the bits in the number and we are anding them just like you're used to doing with any sort of a Boolean expression. If they're both true, it's true. But if one is true or both are false, it's false. So that's exactly how the bitwise AND operator works. So maybe if we go back to the expression, maybe ANDs each bit. So you saw we did that, right? We ANDed each bit in X with the corresponding bit in Y. And then we created a value where if both bits were set to 1, the result was set to 1. So that is exactly what we did here with our little truth table. And that's how when we ANDed 1 and 3, that's how we got 1. Now what happens if we OR 1 and 3? So now, just like if we were doing the logical OR, right, we're going to say if one of these is true, then it's true. So we are going to say A or B, but right, and remember it's a single pipe. So unlike the logical OR, this is the bitwise OR. So 0, 0, 1, 1. All right. So that is our bitwise OR. So now again, if we run this anonymous Apex, right, so we can see A or B using the bitwise operator evaluates to a 3 because we are going to OR those bits. So at each place, if one of them is true, we create a new representation with that resulting bit set to true. All right, so that is how your your bitwise and your bitwise OR work. If we wanted to shift our bits to the right, or excuse me, let's open up our documentation. And I'm going to say we want to shift left. We're going to show shift left first. Shifts each bit in X to the left by Y bits. So now let's show what that looks like. Okay, we are going to, so now we have the number 4. And we are going to use the bitwise shift left operator on 4. So we're going to say system debug C 1. So what I'm doing here is I'm saying shift all the bits in 4 left 1 place. So what that's going to result in, remember right here, that's the 4's location. We're going to shift everything over. So now we have 1, 0, 0, 0. So we moved our bit that was in the 4's to the 8's. 1. so we don't blow that up. Let's run it. So this now becomes the same thing as multiplying by powers of 2, right? So if I changed shift left to 2, all right, we're going to get 16. Very cool. Now we can go exactly the opposite way by shifting right. All right, so we are going to change that up. C1. Now we're going to shift all of our bits in 4 to the right, one place value. So we're going to move that bit from the 4's location, remember base 2, to the 2's location, base 2. There we go. I'm not sure why the value didn't pop up. So there we go. So now we can see when we do why did I just forget the actual name? Bitwise, Bitwise, just Bitwise Shift Left, Bitwise Shift Left, Shift Right. That is how so we can use those to multiply and divide. So that is real down to that. Those are your basic Bitwise operators. We use, remember, and if the values at both numbers in their base 2 values are true, we get a corresponding bit back of 1. Or if one of the values in their base 2 location is true, we get back a corresponding value of a bit in that location. We can use right shift and left shift to move everything to the right or left by the value that we provide here, to shift it to the next value over. And our last one that we want to look at, so I'm going to show, so here's a little common trick, is I'll show you in the code. So over here, we have this method, this may be a separate video, right, where we do show how we can do addition with Bitwise. And then we combine all of these steps. Today, I'm just going to show a real easy thing to do is to check if a number is even, right, using Bitwise operators. So we have here this method, returns a Boolean, name is even, takes an integer, x, and it's going to return the Bitwise evaluation of x and 1 is not equal to 1. So remember what we're going to do. Let's just say if we passed in the number 4, okay? And we'll say 4 has a 0 in the 8s, 1, we're just going to give it 4 bits. All right, 4 bits, okay? And then we are going to AND it with 1. So 0, 0, 0, 1. If you remember our AND, right, this is going to result in a 0, right? So this is AND, right? AND, or the number 1 always just has that 1 bit in the 1's spot. And we can use this to determine if any number is even or odd. Because if it is even, right, it's not going to, when we AND this, 0, 0, 0, 0, right? Because the only place it could ever possibly be true is on the 1 spot in base 2. And because we're only comparing it to the number 1, right? And all odd numbers are going to have a bit there at that placeholder in base 2. So when we do that, we say x and 1, in this case, if it's not equal to 1, right, then we know, hey, that's an even number. If we were to pass in 5, right, so let's change our binary 4 to the binary 5. Now you can see, right, we are going to x, because x is 5 now, x and 1 is going to equal 1. So, right, because we go here, that's a 1. 0, 0, 0. So x and 1 would equal 1, and that would return back an odd number. So if we go back to our anonymous Apex, and let's just do a system debug. I'm going to do Bitwise basics dot is even 4. That should return a true for us. true. All right? 5. Run it again. That should return a false. So there we go. That is the basics of the Bitwise operators in the Apex programming language in about 15 minutes. You may not need them a lot, but you may not need them ever. But if you're like me, you just like to dig in, you like to understand these things, and to me it's part of being a complete programmer, a complete software engineer, is understanding all of the tools that are at your disposal in the programming languages that you work with. So I hope this was useful to you. Let me know in the comments what you think, if you'd like to see some more videos on this type of material. And again, I will see everybody in the next video. Keep practicing, and I'll talk to you soon.